In this video, we're going to talk about solving inequalities. Inequalities are going to be like greater than, less than, or greater than, equal, less than, or equal signs. What you're going to find is, you may not remember how to do it, but when we go through the first couple, it's pretty simple. Let's take an example like this. 2 minus 3x is greater than x minus 6. Now, when you go to work the question, if you just imagine that this is an equal sign, you're going to do the same thing in algebra that you've always done. We're going to have the x's on one side, and we're going to have the numbers on the other. So I'm going to move this x to the other side. So minus 3x minus 1 is a minus 4x. I want to move the number to the other side. Is greater than minus 8. So if it's algebra, negative 4x, I need to divide by negative 4. Here's the little trick you got to remember. Those go away, and negative divided by negative becomes positive, but I divided by a negative, the sign flips. X is less than 2. If you divide by a negative something negative, you have to flip the sign. So it from a greater than to less than. If you wanted to check yourself to make sure you're right very quickly, x, anything that's going to work in this equation has to be less than 2. So let's pick 1 real quick. So if I put in a 1 here and a 1 here, 3 times 1 is 3, so 2 minus 3 is greater than 1 minus 6. Let's see if that's right. 2 minus 3 is a minus 1 is greater than minus 5. And that's true. So I know that that's true. Minus 1 is actually a greater number than minus 5. So I could actually check myself along the way. Most times you don't have to. Just remember that if you divide by a negative, you have to flip the sign. Now, many times what's going to happen is they want you to graph, or they want to have a number line of some sort that goes with your answer. So here's how we're going to do that. Let's say we had one like this. X minus 3 is greater than or equal to minus 2. When you solve this equation, leave the x, move the number to the other side. So x is greater than or equal to 1. On a number line, 0, 1, 2, 3. So I have 3 and negative 3. I'm going to go, it's going to be a 1. And notice it says equal, so I fill it in. So anything greater than or equal to 1. That's what the graph would look like. So x, anything that's going to work in this equation has to be greater than or equal to 1. So 1 works or anything bigger. Let's look at another one real quick. The one we had just a second ago where we had our answer was minus 4x greater than minus 8, and we ended up dividing by minus 4. We just did this one. And x had to flip the sign to be a 2, less than 2. And so what a graph like that one looks like, 0, 1, 2, 3. This is a negative 3, and this is positive 3. So it's going to be, it's not an equal sign here, so it's an open circle. Anything less than 2, so anything this way is the answer to this equation. Okay? So notice if it had the equal sign, I would fill it in, but it doesn't have it filled in, so it's just an open circle. Let's try another one. Let's say we had one like this. 10, and there's 4 plus 2x. Well, that one looks different. I have an inequality on both sides. And so how am I going to work that? So it's sort of like 2 of them put into 1. So what we're really going to do is we're just going to leave the x in the middle. So that means we've got to move the numbers outside, because you see there's numbers on the outside. So I'm going to take out a 4. Here's a little bit of a trick here. If you do it on this side, you have to do it on this side because it goes with both. So 6, 2x, 24 minus 4 is 20. Now I didn't divide yet by anything, and so the sign still stays the same direction that it is. Now it's 2x. I want to solve for x, so I'm going to divide by 2. And so 3, was it a negative? No, so I don't flip the sign. So 6 divided by 2 is 3. The 2's disappear. 10 divided by 2. 20 divided by 2 is 10. So when I make my number line, what I'm basically going to have, 3 and 10. But okay, so let's say this is 0. 1, 2, 3, 4, 5, 6, 7, 9, 10. Alright, so there's my 10. There's my 3. So I could take this apart and say x is greater than or equal to 3. That's this part. And x is less than or equal to 10. Okay, so let's take the first one. X is greater than or equal to 3. The equal sign, so I'm going to fill it in, so I'm going to go that direction. And then with 10, that's an equal sign also, so I'm going to fill it in, and it's less than. Okay, so anything in here is the solution to this inequality. And so I just do it slowly, work it like algebra. If I confused you on that, pause, back up, watch it again. All I did was break it up here into its two parts, and then I graphed both parts, and so that ends up being the graph. That's what they would look for. Now, when you're in the middle of doing these, sometimes they're going to ask you absolute values. And this is something that you probably haven't seen in a while, so I'm going to show you real quick. Anytime you have an absolute value, that means your answer is always positive. So let's say, for example, I had a -5. -5 plus 4 is a -1. Absolute value of that is a 1. Now, I don't want to put that in there because 1's not equal to 12, but that's how an absolute value works. Now, how do you solve things that are absolute value? Here's how you solve this. Watch carefully. I want to make the absolute value disappear. So I drop it, and I have two answers. X plus 4 is 12, and x plus 4 is -12. Now notice what I did. I put a negative on that to make the absolute value disappear. Let's see if that's true. If I solve this one real quick, I'm going to subtract 4 to go to this side. 12 minus 4 is 8. Well, let's check it. 8 plus 4 is 12. So absolute value of 12 equal to 12? Sure, that makes sense. But what about this bottom one? This one seems weird. If I subtract 4, x is -16. Is that an actual answer for this equation? -16. If I put a -16 there, -16 plus 4 is a -12. The absolute value of -12 is 12. So whenever you are solving an absolute value, you can drop the absolute value by having both versions. So in this case, both versions look like this. X plus 4 is 12, and x plus 4 is -12, and you just solve it. So there were two answers, 8 and -16. And I just showed you how to do the math on both of those. So what if it looks a little bit different than that? Let's say if we had that same looking one like this, but it's an inequality. Well, you do exactly the same thing. X plus 4 is greater than or equal to 12, and you would solve it, and x plus 4 is less than or equal to -12. Now notice the sign flipped. Why? I added a negative. Because with inequalities, when you end up dividing by a -1, it flips, so it had to flip. So when I wanted to get my two answers, what I would do, let me move this one down, is I would just do the normal math, pretend like it's an equal sign. I'm going to subtract 4. So x, that goes away, is greater than or equal to 8. There's one of my answers. And when I solve this one, -4, that's gone. X is less than or equal to -16. And so it sort of looks like the first one. Okay, so I can get my solutions by doing this. And so I can graph it. I can make a number line, and I can go to 8, 2, 3, 4, 5, 6, 7, 8 is greater than or equal to 8. There it is, my graph. If I want to go less than or equal to -16, I'd make my number line, and I go less than or equal. So I'd go far left, and I'd have my answer. Okay, so there's another example. What if I had another one that looked just like that except flipped? What if it started with a less than? Then I do the same thing. X plus 4 is less than or equal to 12. And x plus 4, what do you think is going to happen when I switch it? I get a -12. And then I can solve it just like I did and get my two number lines. It's not very difficult. It looks very, very similar to the other ones. It's just we're not used to using absolute value all the time. All right. In the next section, you're going to get to try some of these on your own.